My name is Prithvi Shanath and I am the TA for this course, Engineering Mechanics. I am a PhD student in the Department of Aerospace Engineering at IIT Madras. This is week 5 for this course, and in this week we will discuss problems related to virtual work. So this is the first question. All externally applied loads on a system invariably contribute to virtual work irrespective of the direction of virtual displacement introduced. So can someone tell me what will be the answer to this question? See, all externally applied load. So what if the applied load is perpendicular to the virtual displacement? In that case it would be false, right? So it's not always true. Suppose the force is perpendicular to the displacement. In that case, work done is 0, right? Did you understand? Yeah. So it's not always true. Now the next question, the potential energy of a mechanical system is given by this expression where theta is the independent coordinate that defines the single degree of freedom system. The value of theta in radians for which the equilibrium is unstable. Now V is given. Can you try solving this question? You know V, so you have to find out theta such that the equilibrium is unstable. So you can see the question properly. Did you get the answer to this? Did you get the answer to this? Okay, so I'll solve the problem. So the potential energy for the system is given by 5 theta to the power 4 minus 3 theta square plus 6. So for equilibrium, what should be the condition? Can you tell me? For a system to be in equilibrium, what should be the condition? first we need to find the first derivative, right? Yeah. So dv by d theta is 20 theta cube minus 6 theta. Now for equilibrium, this should be equals to 0, right? So 20 theta cube minus 6 theta is equal to 0. So if I take theta common, 20 theta square minus 6, which is equal to 0. So here theta can be equal to 0, or 20, or another possible solution to theta is theta square minus 6 equals to 0. So theta square equals to 6 by 20, right? Now we have to find theta such that the equilibrium is unstable. So when can we say that the equilibrium is unstable? When the double derivative is less than 0, right? For unstable equilibrium, this should be less than 0, right? Is this clear to everyone? Okay. Now I will differentiate this expression once again. So this becomes theta square minus 6. Now I know that I know the value for theta, right? 0 and square root of 6 by 20. So which of these values will give this expression less than 0? Of course theta equals to 0 will give. So if I substitute theta equals to 0, then only this expression becomes less than 0, right? Is this clear? That if I substitute theta equals to 0, then only this expression is negative, right? Less than 0. Is this clear? Yeah, you can ask. Yeah, you can ask if you have doubt. It is the condition, right? In the lecture, sir has discussed, right, for the conditions for stable, unstable and neutral equilibrium. it was discussed in the lecture. So, yeah. So I'll write the write the conditions for several equilibrium. For stable equilibrium, should be 0. For unstable equilibrium, it has to be less than 0. So these are the conditions. Is it clear? You can watch the lectures. Is this clear now? Yeah. So the next question. An assembly of 3 identical members connected by smooth pins and a linear spring with spring constant K equals to 20 Newton per meter. The assembly is acted upon by a force P equals to 4 Newton as shown. Use the method of virtual work to find the angle theta in degrees for equilibrium. The spring is theta equals
What
0.
was the answer of last question?
Huh?
What was the answer of last question, ma'am?
The answer is 0. For theta equals to 0, d square v by d theta square is less than 0, right? If I substitute theta equals to 0 in this expression becomes less than 0, right? So for theta equals to 0, the system is in unstable equilibrium.
Okay, ma'am.
Okay. Yeah. So for the next problem, this is a system where the spring constant is 20 Newton per meter and force is applied at this point and it is equal to 4 Newton. You need to find angle theta such that the system is in equilibrium. So can you and it is mentioned that frictional effects can be ignored. So can you try solving this problem? So can you try solving this problem? Could anyone do the problem? Okay, so I'll solve the problem. So when the force is applied here, let this be displaced by del theta. Now, so to calculate this del theta, so for small displacement, I can say that this is displacement till delta theta, right? Sorry, not delta theta. This should be, suppose this is displaced by delta H. Okay, and suppose after this giving small virtual displacement to this link, let this be delta theta. Now what will be delta H? Can you tell me? Delta H will be 0.8 delta theta, right? Did you get that? Like this displacement is so the work done by P, work done by P would be P into 0.8 to delta theta. Now there is also a spring attached to the system, and it is said that at theta equals to 0 the spring is unstretched. Now, so we can say that in this configuration the spring is in stretched condition, right? Since theta is not equal to 0. Now what can I write? Now potential energy in the spring suppose this displacement is delta x, okay? Now what is the expression for x? I can write x as 0.8 sine theta, right? Is there any doubt regarding this? This is 0.8. So x can be written as 0.8 sine theta, right? Yeah. So delta x is 0.8 cos theta delta theta. Now, so the potential energy in the spring becomes delta V becomes K into 0.8 sine theta into this delta x, right? 0.8 cos theta delta theta. Is this clear? Yes. So I'll just equate these two. P into 0.8 delta theta equal to K 0.8 whole square sine theta cos theta delta theta. I'll just cancel these two. Can you try solving this question? I think there's some problem. I'm coming back to this question later. So let's solve the next problem. Can you try solving this question? I'll solve this question, that question later on. You just try solving this question. Could you solve this problem? So this is the question. If D is the horizontal distance of the point of application of P from the support A, what is the magnitude of virtual displacement delta D in terms of B? So this distance is given. Right? So you need to find delta D in terms of, now, so from here I can say this much is 2B. So this angle is theta by 2, right? So this much distance is 2b sine theta by 2, and from this triangle I can say this is b sine theta by 2, right? Is this clear? Yeah. So the total distance d is d is what? D is d equal to 3b sine theta by 2, right? So delta d would be 3b cos theta by 2 half delta theta, right? So I can write this as delta d equals to 3b by 2 cos theta by 2 delta theta. Is this clear? Okay, so the second option is correct. Now the next part of the question, what is the relation between theta p and m that must be satisfied in order to maintain equilibrium under the action of p and gravity? So gravity is also acting at these points, right? Now what will be this distance? Can you tell me what will be this distance? H. This is B, this is also B. It will be B cos theta by 2, right? This angle is theta by 2. Is there any doubt? So H will be B cos theta by 2, right? Did you get it? Okay, so del H would be minus B sine theta by 2 half delta theta. Now I'll take the magnitude of this. We can see that gravity, the force of gravity, the force and the displacement are in opposite direction, right? So there will be a negative sign in the equation. and the displacement due to P is in this direction only, towards the right. So the work done due to P would be positive, right? And the work done by gravity would be negative. So I can write it as P into, what was delta D? It is 3b by 2 cos theta by 2. So 3b by 2 cos theta by 2 delta theta minus 2 mg. So mg b by 2 sine theta by 2 delta theta equal to 0. Now b by 2 gets cancelled. So 3p cos theta by 2 minus 2 mg sine theta by 2 equal to 0. So I can write this as tan theta by 2 equal to 3p by 2 mg. Is this clear? Is this thing clear? Yeah. So theta by 2 is tan inverse of 3p by 2 mg. So theta equals to 2 into tan inverse of 3p by 2 mg. So this is the final answer. So which option is correct? 3p by 2 mg. Yeah. So the fourth option is correct. Is there any doubt regarding this problem? Okay. So the next part. Given that each member has a mass of 0.8 kg, what will be the angle theta between the members in degrees when the assembly attains equilibrium with P equal to 35 newtons applied? So I just simply need to find out this theta, right? Every data is given. So can you tell me the answer to this question? You just need to substitute the value and tell me the answer. Yeah. So I'll just substitute 2 into tan inverse of 3 into 35, 2 into m. M is 0.8 and G you should take as 9.81. So it is 162.996 degrees. So the next problem. Two links of mass m are connected and constrained as shown. A massless rod DEF is connected to the links at E through a collar and F with a linear massless spring in portion DE of spring constant K. With the application of horizontal force P, the angle theta between the links increases, thereby compressing the spring. It is known that the spring is uncompressed in the position when theta equals 0. So, if the question, if D is the horizontal distance of the point of application of P from support A, what is the magnitude of virtual displacement delta D in terms of B? So you need to find this distance D, and after that you need to find delta D. So can you try solving? It is more or less similar to the previous problem, almost similar. Can you tell me the expression for D? Yes. Yeah, that's correct. Okay, I'll solve this. So from this figure you can see that this is 2B. So this part is 2B and this is theta by 2. 2B sine theta by 2. Similarly, this distance is also 2B sine theta by 2. So D equals to 4B sine theta by 2. Now differentiating this will give 4B cos theta by 2 into half delta theta. So delta D would be 2B cos theta by 2 delta theta. So this is the answer. So the third option is correct. Is there any doubt regarding this problem? Okay. So the next part. What is the correct expression for the elastic potential energy stored in the spring? It's very simple. Just you need to substitute for x in the expression for potential energy for a spring. It's very simple. Just look at the figure and you can do it. Just try solving this. So can you tell me the answer? Can anyone tell me the answer now? So this is the figure. So I'll solve the question. So what is x? Now we know that the potential energy for the spring is given as half kx square, right? Now what is this x? X is this distance, right? It is mentioned in the problem that the spring is uncompressed when theta is 0. So x is this distance, right? So what is this distance? Can anyone tell me x? What will be this x from this figure? Can you tell me? This is b. So this would be 2b sine theta 2. Theta by 2, right? Yeah, right. So just substitute this. So half k 2b sine theta by 2 whole square. So half k 4 sine square theta by 2 2k b square sine square theta by 2. So which option is correct? This third option is correct, right? Is there any doubt regarding this? Okay. So the next part of the problem. Which of the following expressions correctly represent the total gravitational potential energy of the system with respect to the datum and positive coordinate axis shown? So total gravitational force with respect to datum. So this level is datum. You can see from the figure. It's very simple. Just tell me what will be the answer. So mg would be acting here. So what will be the potential energy? what would be the gravitational potential energy for the system? This level is datum, so it will be negative, right? Can you tell me what will be the gravitational potential energy? So can you tell me what will be the gravitational potential energy? So first tell me, will it be positive or negative? This is the datum level. So will it be positive or negative? Can you tell me that? It will be negative, right? So Vg will be 2 mg, and what is this distance? What is this distance? Can you tell me what will be this distance? This is b, right? And this angle is also theta by 2. So what can you say about this height? What will be this height? Can you tell me what will be this height? It will be p cos theta by 2, right? Is this clear? So the potential energy would be b cos theta by 2 mg into b cos theta by 2 and minus, because it is below the datum level. See, this is the datum level, so mg is acting below it, so it will be minus 2 mg b cos theta by 2. So this is the correct option. Now, next part of the problem. Determine the force P in Newton which will produce equilibrium at the angle theta 45 degree with spring stiffness K equals 1 Newton per millimeter and B equals to 100 millimeter and mass M equals to 2 kg. Can you try this out? Just write the virtual work equation and solve it for P and substitute this given values. You will get the answer. So just look at this figure and try to write the equation, the virtual work equation in terms of work done by this P and the potential energies which we just calculated, and then substitute the values and you will get the answer for P. So I'll solve this problem. So del W equals to del of potential energy stored in the spring plus del of potential energy the gravitational potential energy, right? So Vg. So del W is the work done, virtual work done by the force P. So P into what was the distance that we calculated? Delta D. It is 2b cos theta 2 by delta theta, right? So P into 2b cos theta by 2 delta theta equals to del of potential energy stored in the spring. So we got that to be 2kb square sine square theta by 2 plus delta, no, it was in minus, so minus minus 2mg b cos theta by 2. And there is a del here, so write it as minus delta 2mg b cos theta by 2. So now I need to differentiate this. 2pb cos theta by 2 delta theta equals to 2kb square 2 sin theta by 2 cos theta by 2 into half delta theta. This is for the first term, like this term. For the next term, it is minus 2mg b sine theta by 2. So again there is a minus if I differentiate cos theta by 2 into half into delta theta. So finally this becomes pb cos theta by 2 delta theta equals to kb squared cos theta by 2 sin theta by 2 delta theta plus mg b by 2 sin theta by 2 delta theta. Now I'll just cancel delta theta. So this becomes P equals to kb sin theta by 2 plus mg by 2 tan theta by 2. Now I just need to substitute the given values. K is given as 1 Newton per millimeter. Theta is 45 degree. K equals to 1 Newton per millimeter. B equals to 100 millimeter and M equal to 2 kgs. So P equals to 1 into 100 sine 45 by 2 plus 2 into 9.81 by 2 into tan of 45 by 2. So this becomes finally 42.33 Newton. Now I'll go back to this question. So for this problem, it is said that an assembly of 3 identical members is connected by smooth pins and a linear spring with spring constant K equals 20 Newton per meter. The assembly is acted upon by a force of 4 Newton. Use the method of virtual work to find the angle theta in degrees for equilibrium. The spring is unstretched when theta equals to 0 and a smooth roller support is provided to keep the spring invariably horizontal. Now, suppose let this be H. So I can write H as H can be written as 0.8 cos theta. So delta H would be 0.8 minus sine theta delta theta. I will take the modulus of this. So now, and I need this delta x. So I can write x as this distance is also 0.8. So x is written as 0.8 sine theta. So we are discussing this problem. You can look at this figure. So we need to find delta x. Now I'll differentiate this. Delta x would be 0.8 cos theta delta theta. Now what will be this work done? What will be the work done by P? Work done by P would be P into delta x, right? Delta h. P into delta h. And the work done by the spring would be negative since the force and displacement are in opposite direction. So kx delta x equal to 0. Now I'll just substitute this. P into delta h is 0.8 sine theta delta theta minus k 0.8 sine theta into 0.8 cos theta delta theta is equal to 0. Now 0.8 I'll cancel sine theta. So P and delta theta P equals to K into 0.8 to cos theta. Now cos theta equals to P K into 0.8. So theta equals to cos inverse of P by K 0.8, which is equal to P is given as 4, K is 20 into 0.8. So this is equal to 75.52 degrees. So this is the answer, this problem. Now the next problem. A box which weighs W Newton is supported by a massless spring of length B, which is connected to a 7-meter long massless link. A linear spring of spring constant K equals to 500 Newton meter is used as shown, which is unstretched when theta equals to 45, and the mechanism attains equilibrium at theta equals to 60 degree. The frictionless roller provided ensures that the spring is always horizontal and gravity acts in -y direction. Answer the following question based on the given data. So we had solved the second question, second problem. So just see. So this problem I told I'll solve later. So here, let this be h, this distance. So this h would be 0.8 cos theta, right? Just look at this figure. H would be 0.8 cos theta, right? Did you understand? Now, if I differentiate it, delta H would be this. Now I'll take the modulus of delta H. Now I need delta X for the spring. X is 0.8 sine theta. This X, it would be 0.8 sine theta, right? Now in displaced position it would be delta X. Now X will be after displacing it would be delta X. So X is 0.8 sine theta, right? From this figure you can see. Now similarly I'll get delta X from here. So P is doing a positive work because the displacement and the direction of force are in the same directions, whereas the spring is doing a negative work because the displacement and the spring force is in both are in opposite direction. So there will be a minus sign. So I'll just substitute the values for delta H and delta X and X. So I'll simplify this and get the angle for theta. So did you understand this problem? Is there any problem understanding this? So the next problem, so for this problem, at equilibrium the gravitational potential energy of the system is negative with respect to given data. Is it true or false? So the datum is here. This is the datum level. And this link is massless. And the string is also massless. So we just need to consider the weight of this box. So can you tell me if the gravitational potential is negative or positive with respect to this datum level? Can you tell me? So this is false, right? The gravitational potential energy due to this weight is positive with respect to this data. Now we are asked to find which of the following equation correctly represents the total potential energy of the system with respect to the datum and positive coordinate. So for this problem we need to find out the potential energy of this spring and the potential energy, gravitational potential energy due to this weight W. And it is also mentioned that the spring is unstretched when theta equals to 45 degrees. Can you try finding out the potential energy for the system? So first, what is the potential energy due to this weight? Potential energy of box will be what is this distance? This distance is this total distance. What is first tell me what is this total distance? It is 7 cos theta, right? This total distance. So this would be 7 cos theta minus of this distance, that is b. So the potential energy of this box will be 7 cos theta minus b into w, and potential energy of the spring so it is mentioned in the problem that it is unstretched when theta equals to 45 degree. So we need to find the x, that is the extension in the spring. So x will be, x is the, let x be the extension in the spring. So x will be sine theta minus of sine 45 degree. Now, therefore, the potential in the spring will be half k x square k sine theta minus sine 45 degree whole square. So half into k is given as 500. So 500 sine square theta plus sine square 45 minus 2 sine theta sine 45 degree. Now just we need to simplify this. Half so this will be 500 sine square theta and there is one 7, I missed out 7 here, 7 square. So there is 7 square here. Yeah, 7 square plus 7 square by 2 into 500 sine square 45 degree minus 7 square into 500 sine theta sine 45 degree. 1732.4.11 sine theta. So the total energy of the system would be the total potential energy seven cos theta 7 w cos theta minus w b plus 12250 sine square theta plus 6125 minus 1732.4.11 sine theta. So which option is correct? So this is the correct option, right? Is this clear to everyone? Is this clear to you? Is this clear to you? Are there any doubts regarding today's problems? So if there is no problem, we can stop here.